I'd like to welcome everyone to this month's LGU forum that we've been having. And we do have our Tennyson warning here that as of a month ago, we're required to show when we're doing a forum like this. Today's agenda, which is what to listen to, is talking about some of the newer information that we've got nationally. Manny will be talking about ASCE 2424.
So good morning, everybody. Manny Perotin, a civil engineer based out of Tampa, Florida. So not as close, but pleasure to be here this morning. I volunteered as the ASFPM non-structural floodproofing co-chair since 2017. Also volunteered as a member of the ASCE 2424 committee. There's about 40 of us that were involved with this over the past 2 years or so, about 18 months or so, and I've been involved with studying flood-resistant design and construction since about 20 years now, since Hurricane Katrina. So from preparing with Seal and Gary, it's my understanding most of you are involved with floodplain management in some way, shape, or form. For most of you, this is an additional duty versus your full-time job. So plan to give you an overview of ASCE 24, including a brief history, key differences between the requirements in this standard and the National Flood Insurance Program. I'm assuming most of you are familiar with those requirements. And then focus on the changes since the 2014 edition of the standard, which is the previous edition. So I've delivered this presentation to different audiences in a variety of forms. And what several of my colleagues like doing to start off is with the question. And the question ultimately is, as you plan new construction in your community, or state for that matter, what percent chance should those new buildings have to flood over the next 50 years? For residential, that's kind of rule of thumb that we use as a useful life for that building. And when we ask this question in person, the delivery, normally we go through each option and ask the audience to raise their hand. I'll be honest, most people probably answer A and B, A or B for that matter. And again, we're kind of preaching to the choir. Most of our audience is similar to this one, folks that are involved with floodplain management, things of that nature, or just natural hazards and resiliency and things of that nature. For the sake of discussion, I typically answer E as my option, not because that's the way I personally feel, but you'll see here why here in a moment. And that typically catches people's attention. We also poll the audience to gauge whether that requirement or their risk tolerance should be the same for all types of construction. So do you have the same opinion about a house versus, let's say, a supermarket or let's say a warehouse, or for that matter, a hospital or other critical facility? And for the most part, people answer yes, that they do think there should be a difference, different standard, if you would, for something like a hospital versus maybe a single family house. So those are two kind of questions we talk through for a little bit as a group, and then we wrap up with these are the recurrence intervals associated with those percent probabilities over a 50-year period. I mentioned earlier about me selecting option E, and I select that for the sake of discussion because that reflects what our current requirements are. So the 100-year annual chance, or what we currently use as the base flood, that has a 40% probability of occurring over a 50-year period. For option D, as a rule of thumb, the National Fire Protection Association estimates that there's about a 30% probability, about 22 to 30% probability, but 30% is the higher end range of that, of having a house fire that requires a fire department to respond to your house over a 50-year period. Option C, I typically refer to this as rolling the dice. So Mother Nature has a 1 in 6 chance, or about a 16, 17%, almost 20% chance of rolling a specific number. Option B, which is that 10% chance over that 50-year period. This is about the equivalent of what the risk is for a magnitude 9 or greater earthquake or seismic event out in the Cascadia subduction zone. So think of Northern California to Vancouver. And then this 5% chance, or option A, kind of, if you ever played roulette, for those roulette players out there, this is like betting on two numbers. So when you split your chip across two numbers, you have about a 5% chance of that number being hit. So you'll see option A and B later on in this presentation as ASCE 24, and as Seal just mentioned, the ASCE 2424 sets the 500-year and the 1,000-year as two of the different recurrence intervals it uses for the minimum elevation requirements based on the criticality of the building. These are some statistics. ASFPM put these together, or the Association of State Floodplain Managers put these together. The flood losses continue to increase. You can see here, Hurricane Katrina is clearly a blip in this chart. Harvey, Irma, and Maria in 2017 are also events. Both of those jump out at you in this chart. There's also some other major flooding events along the Mississippi. You can kind of see that in the early 90s here, and other events sprinkled throughout. But the bottom line on this slide is that the flooding damages and trends seem to be getting worse. I recently looked at the NFIP, or the National Flood Insurance Program claims, so their open FEMA data. And while flood insurance is mandatory within the floodplain or within the special flood hazard area and makes up most of the policies, about 25% of those claims actually come outside of the special flood hazard area, with the average claim being about the same both in and outside of the flood hazard area. One thing you'll notice, though, if you focus on newer construction or post-2000 construction, you notice the percentage of the claims is slightly higher. So now we have about 30%, or 30-70 versus 25-75. 30% of those are actually occurring outside of the special flood hazard area. And then if you notice that our claims are actually about 10% higher, about almost $100,000 average outside of the special flood hazard area. A variety of these. There's a lot of contributing factors to this. One factor always comes up is, why are they going up? And in general, our houses are larger after 2000 than they were prior to 2000. So you have a larger house to be damaged. So in general, we do see higher claims in newer construction when they are impacted. But one reason in my opinion, for why you see the claims outside the special flood hazard areas having higher claims is that the newer construction within the floodplain is required to meet flood-resistant design and construction requirements, right? We have to meet the CFR, the requirements in the NFIP, whereas newer construction outside the special flood hazard area does not. So this binary approach is relatively ineffective, especially for this newer construction. So enough on statistics. Let's get into to the topic here on ASCE 24. 24 is a consensus standard that establishes the minimum requirements for flood-resistant design and construction of structures in the floodplain. Note the title indicates resistant. It's not flood-proof, so there's still potential to have damage. There's still some level of residual risk there to flood damages. And then the other key thing to note, and I bolded here, is that the scope of the standard is for structures within flood hazard areas. So that flood hazard area has to be delineated in order for this standard to be applied or enforced, if you will. A quick history on 24. This goes back to the standard itself goes back to the mid 90s. I think it may have stemmed from some of those claims that I showed you on those charts in the Midwest. We had damages up and down the Mississippi River. So in the mid 90s, funded by FEMA, the American Society of Civil Engineers produced what they call a pre-standard document on flood-resistant design and construction. And then in 95, the American Society of Civil Engineers stood up the first committee to establish this standard. It consisted of about 40 individuals in floodplain management, construction, techniques, engineers, architects, contractors, as well as those involved with building codes and regulations like building officials and plans reviewers and things of that nature. And very similar to the committee that was just put together with about 40 people for the 2024 edition of 24. And then in 98, they published the first edition of ASCE 24. That's the cover you see here on the left-hand side. And the second edition was published in 2005, and the third edition, or the previous edition, is the one we have right now. It was published in 2014. So when you hear about 2498, 2405, 2414, or now 2424, that second number just has to do with the year in which it was published. And then since 2000, the standard has been referenced in model building codes. So if you follow the International Code series, the I codes are also often referred to as the International Building Code and the International Residential Code, as well as the codes developed by the National Fire Protection Association, often referred to as NFPA 5000. Since about 2000, those codes have incorporated ASCE 24. So the 2000 through 2024 editions of the I codes They're all include these, and by including ASCE 24, that means they're consistent with the NFIP, National Flood Insurance Program regulations. With respect to the NFIP, that establishes the minimum design and construction requirements for buildings within the special flood hazard area. These are outlined predominantly in Part 60 of the 44 CFR. And for the most part, these have gone largely unchanged in the past 50 years. Note these, if you notice on the previous slide, I mentioned earlier that most of that standard development, things of that nature, incorporating these into the building code started in the mid-90s. So these requirements existed for about 20 years before formal, consistent adoption of any of these in the building code. So predominantly relied on that floodplain management ordinance at the state and local level to implement and enforce these requirements. Now, since the mid-90s to early 2000s, it's been supplemented by, in essence, the building department having to make sure that these are properly adopted and enforced as well. The standard itself provides the minimum requirements for flood-resistant design and construction of those structures that are required to meet building code requirements or subject to floodplain management regulations. Sometimes ASCE 24 isn't adopted at the state and local level by a building code. Instead, it's adopted by let's say, a local floodplain management ordinance. The overall intent is to convey the NFIP requirements. So by following ASCE 24, you should be meeting or exceeding the requirements and the NFIP. And these requirements, similar to the triggers that exist under the National Flood Insurance Program, they apply when they're within the flood hazard area, and they apply to new construction, so something that's being newly built or potentially something that's being substantially improved or that suffered substantial damage. All right, so hopefully that gave you a good background on the standard for those of you that weren't familiar with it and tried to kind of draw some parallels or at least offer some parallels between it and what's in the National Flood Insurance Program or what's in Part 60 of the Code of Federal Regulations. Now I'm going to focus on some key changes that occurred or that are being introduced in the latest edition of the standard. Again, this is the 2024 edition compared to the 2014 edition. The first piece is that we now have a risk-based approach to elevation. What does this mean? So traditionally speaking, most floodplain management ordinances and for that matter, even ASCE 24-14, they handled something like freeboard by simply adding 1, 2, or 3 foot of elevation to the base flood elevation based on the criticality and potentially the location of the building. So in, like, for example, in ASCE 24-14, you may have more freeboard in a coastal V zone than you would throughout the rest of the floodplain. Or you may have additional freeboard for a school versus a house. So keep in mind, with that being said, not every floodplain is the same. So adding 1 or 2 foot does not necessarily provide you the same level of protection. And that's one of the points of emphasis that the ASCE 24 committee had in moving to this approach. And you can see here, I have 1 foot of freeboard, and in this floodplain where there's only 1 foot of difference between the 100 and the 500, then I am meeting that 500-year level of protection by adding a foot of freeboard. The larger that difference becomes, the less flood risk reduction that 1 foot of freeboard is actually providing. So again, we move to a risk-based approach to elevation, and 24 moves to basically using a recurrence interval-based elevation, which allows it ultimately for providing a consistent level of protection across all floodplains. Now, keep in mind, this is based on the flood design class of the building. And by flood design class, what I mean by there is I talked earlier about what % probability would you find acceptable or tolerate within your community for new construction over the next 50 years. And then we also talked about, would you have that same level of risk tolerance based on the criticality of that building? So most of your houses, your single family construction, your duplexes, things of that nature, they're going to fall into this flood design class or risk category 2 building. So under ASCE 24, you're going to follow the 500-year mean recurrence interval as the basis for your design flood elevation. If you're building something like a nursing home or a school, that'll be a risk category or flood design class 3. That'll be required to be elevated to the 750. And if you're building a critical or essential facility, such as an emergency operations center, a hospital, things of that nature, those will have to be designed to the 1,000-year recurrence interval. Right. So hopefully that gives you an overview of the elevations, if you would, or the MRI-based or flood risk-based elevation requirements. To illustrate this point further, I have a few slides here illustrating, how not every floodplain is the same. These are 3 different floodplains. Pretty sure these are all in Ohio. We use this presentation for a lot of recent deliveries, and these are examples in Ohio. But from left to right here, you have about a 3-foot difference between the 100 and the 500-year flood elevation, a 2-foot difference, and a 1-foot difference between across these are different watersheds, different rivers throughout Ohio. But again, trying to illustrate the point here is that 1-foot of freeboard doesn't always provide you the same level of risk reduction. So in essence, we're going to the 500-year instead, at least for homes and risk category 2 buildings, which is your most common type of construction. And we're even going further beyond that for more critical facilities. This slide here is an example in the vicinity of Minneapolis. And here you can see the profile along the Mississippi River. And if we zoom in on this a little bit more detail here, you can see here, even just within this short distance along the river, you can have a difference of anywhere from 1 to 3 feet. Looks like the predominant difference in this area is about 2 to 3 feet. But again, trying to illustrate the point here in terms of the difference between the 100 and the 500 year, and making sure we're getting anything new that we're building is being protected to at least the 500-year flood elevation. Another key difference or key attribute in 2424 is the floodplain extent. And I realize there's a lot of text here on this slide, but these definitions and content is pulled directly from the standard. So I'm just trying to highlight 2 key points here. The 2024 edition of ASCE 24 expands that flood hazard area to the 500-year floodplain. So the definition of the design flood in ASCE 24 was adjusted accordingly. Before, it just used to be the special flood hazard area or the base flood. Now we're expanding to that 500 year. So again, it's pointing to the definition in section 1.3. And then when you go to the definition in section 1.3, it specifically states that it's within the mapped 500-year floodplain. So not every flood insurance rate map in the country has a shaded X zone or has this 500-year floodplain delineated. So the committee wanted to make sure that it had to be mapped. Now it could either be mapped on a flood insurance rate map, or let's say in Minnesota, the DNR provides a product that shows you the 500-year flood hazard area. That can also be whatever's adopted by the community. So it either can be on a flood insurance rate map as delineated on that, or those that flood hazard map that's adopted by the community. Either or. The key point of emphasis here that the committee wanted to make sure was that it was mapped, and it's not on the developer or the design professional to figure out whether or not this area is or is not within a 500-year floodplain. So it has to be mapped in order to apply, at least if you're adopting the standard as it's written. So when following 2424 and using a firm, again, if you're in this shaded X zone, so that island I was showing you earlier in Minneapolis, it would apply here on this island. If I come up here a little bit further northwest of that island, traditionally speaking, our floodplain management ordinances, our Code of Federal Regulations, the NFIP, they regulate construction within this A zone, within this floodway, etc. Now it would be expanded to the shaded X zone if you're applying ASCE 24. And again, this is a map view. This is a profile view. I know there's not too many coastal floodplains or coastal V zone floodplains, so I'll focus on this example here, this profile here on the bottom. So your non-coastal floodplains will typically have your A zone with your floodway delineated within that A zone. You see that here on this map, and then they'll also have a shaded X zone. So this standard is now expanding the flood hazard area to this shaded X zone or the 500-year floodplain. So moving to a risk-based elevation, in my opinion, further exacerbates what we call the waterfall effect of the current NFIP. So this is kind of the binary approach. You're either in or out of the floodplain, right? So this is the limit of the 100-year floodplain. You're in it, you're out of it. We regulate you here, we don't regulate you out here. But now with these additional elevation requirements, whether you're using freeboard, which is what we've used traditionally, or if you assume the difference between the BFE and the 500 year is 1, 2, or 3 feet, we have buildings that are being built within the 100-year floodplain that are much higher, potentially much higher than those built immediately outside of it. So we call this the waterfall effect, and this waterfall effect, it was also relatively illustrated to you through those flood insurance claims that I was showing you earlier. In new construction, we're seeing that the claims out here are about 10% higher than in here for newer construction. And that's because these buildings being built here are being elevated, where buildings here aren't. So we're seeing more damage, or higher damages, if you would, out here in this 500-year floodplain. So the goal behind this is to, in essence, expand the extent of the 500-year floodplain, and the binary effect will still exist, but it should not be as hazardous, if you would, by extending this out to the 500-year floodplain. Hopefully that gives you a basic overview of the risk-based approach, both from an elevation standpoint and from a flood extent or flood hazard map extent standpoint. I'm now going to walk through kind of recent case study here from Hurricane Helene in Tennessee to hopefully help illustrate this elevation and floodplain extent example. So this is a hospital built in Irwin, Tennessee, in Unicoi County. This hospital was opened in 2018. And based on news reports, it's about a $30 million facility, about 40,000 square feet. And unfortunately, during Hurricane Helene, this hospital experienced pretty significant flooding, and over 50 people had to be rescued from the roof at this facility. So we saw this example, and we were curious about it, and we looked at, you know, how different would things have been had ASCE 2424 been in place and been incorporated here. And this is an example of a floodplain that the decisions, if you would, that are being made, or the changes that are being made in 2424 are geared towards. There's a 6-foot difference. You can see that here on the left-hand side. There's a 6-foot difference between the 100 or the 1% and the 0.2% chance of flooding based on the flood insurance study or the profile at this location. So what does ASCE 2424 require here? This is table 1-3 out of the standard, and ultimately walks you through how you estimate your design flood elevation. The design flood elevation, or FE sub MRI, ultimately that's the elevation you have to build to, and that mean recurrence interval varies based on the criticality of the building. So this row here, flood design class 2, this is referring to houses, if you would, residential buildings, things of that nature, probably your most common type of construction. 750 is additional level of criticality, like flood design class 3, or the buildings that are built to the 750-year recurrence interval. These are things like schools. And then finally, flood design class 4, these are your most critical facilities, such as your hospitals, like this scenario that we have here. If that information is available, if you have the 500-year flood elevation, then you just apply method A. If I have a house that I'm building and I know the 500-year flood elevation, that's all I have to build to. We also know, or a lot of people on the committee realize, that most flood insurance studies across the country may or may not have this information. So there's other methods here to help you estimate that elevation based on the information you have available to you. So let's say I'm building a house and I don't have the 500, but I do have the 100 and the 10-year based on the flood insurance study, then I can estimate it off of that. Same thing, most people, I'm very confident saying most parts of the country don't have a 750 and 1,000. There's ways to estimate what that would be based on having the 500 and the 100, or the 100 and the 10-year. And even for that matter, let's say you don't have any of that information, all you have is the 100-year, then there is going back, if you would, to a freeboard approach of 2.1, 2.6, and 3 feet, depending on the criticality of the building. And the way these numbers, freeboard values, were estimated is there was an analysis done of the entire country and ultimately looked at the average of the 50th percentile of a population weighted data set. So took buildings inventories that were across the country and characteristics of those floodplains, and came up with those freeboard approaches for the different flood design class of the buildings. That's the elevations, or how you establish your elevations according to the new standard. There's also a flow chart in the document to reinforce the point that you don't have to go through every method on that previous table. If you have the information in front of you, if you have method A, if you have the 500, the 750, or 1,000 established either on the floodplain map, or let's say a community has done the study and they've established what that is for their entire community, then there's no reason to keep going through methods B, C, D, and E. Again, all these different steps are trying to work with what's the best available information. If you have it, then work with that. If you don't have sufficient information, then here's other ways to best estimate the information. We understand, or the committee understood, that there's probably a lot to handle on that chart, a lot of calculations that potentially have to be made. So the LSU Ag Center, Dr. Carol Friedland, I'm not sure if any of you are familiar with her, but she was on the committee. Her and some of the students there, they created this web-based tool, if you would, that just allows you to enter in the information, and it tells you what your design flood elevation is. So if you tell it, what kind of building you're constructing, what kind of floodplain you're in, and what the base flood is, it'll estimate the design flood elevation for you. So based on this form here, the screenshot, we had a BFE of 7, and it's estimating that the minimum required elevation based on ASCE 24 is 9.1 feet. And again, this is likely because there was limited information available, data was not available, so it just applied our freeboard method, if you would. But in this case here, I'm going to go back to the hospital, kind of walk you through the tool a little bit further and show you how you could use other information besides that freeboard or a method to estimate what the design flood elevation is. So here, again, I'm assuming most of you are familiar with flood insurance studies, at least reading a profile, but what would the DFE be for the hospital under ASCE 24? Notice this is cross-section K right here, and the hospital is just a couple hundred feet upstream of cross-section K, and the BFE here is about 1655. So I'm going to go into that profile that I had up earlier on the screen. I showed you that there was a 6-foot difference between the 100 and the 500 here, and I'm going to look specifically at the location of the hospital. So here's cross-section K. I said I'm a couple hundred feet upstream of that. So here's a red line marking where the hospital is located. I zoom in a little bit further on there. And as you can see here, I have the 10, the 50, the 100, and the 500-year elevation available to me across the location of that hospital. If I read those elevations, here's that 1655 I mentioned earlier, where that's with the BFE here, and that's consistent with the 100-year. See that reading right there of 1655. I'm estimating the 500-year is about 1662, and that the 10-year is about 1648. And then if I also looked at the USGS site, and I just added on here for context for folks to have a general understanding of what the topography is like here. The location of the hospital is about an elevation of 1659. So it was about 4 feet above the BFE and about 3 feet below that 500-year flood elevation. Now I have most of the information that I need. And again, here's a profile view of that hospital. And here's the firm, the flood insurance rate map, and the USGS topo profile here at the bottom. Currently speaking, this hospital, if you follow most floodplain management ordinances or you follow the CFR, this building is outside the floodplain, so it wouldn't be regulated. But under ASCE 24, because we've expanded the flood hazard area and the 500 years delineated, this would fall under the requirements of ASCE 24. So it does apply to this. Let's say we were building it new. And now what would our design flood elevation be? So it's a risk category 4. It's in a riverine floodplain. We're telling it, the tool, it's in a shaded X zone. We had read the BFE of 1655, both off the firm and off of the flood insurance study, and off the profile in the flood insurance study. And then we have an elevation, a 500-year flood elevation off of the profile of 1662. So my design flood elevation for a risk category 4 building here, based on using this tool, and again, I didn't have to do any of the math that was in that chart, would be 1665. Again, this is an estimate based off of using the 500 and the 100-year elevations. So 1665, and I told you earlier that the elevation of that grade here was about 1659. So this building would have been built about 6 feet higher than it was at the time it was built in 2018 when they just had to, again, there was no design flood elevation requirements when this was built because it was outside the special flood hazard area. Let's say, for example, the community wanted to build a school just west of the hospital. Again, under current requirements, we're now in the floodplain, so it would at least have to be built to the BFE of 1655. But let's see what would happen under ASCE 24. Again, very similar. The main difference here is I'm telling it it's a risk category 3 building. So now it's going to estimate what the 750-year elevation would be. Same inputs, right? 1655 for my BFE, 1662 for my 500, and my design fill elevation for a risk category 3 building would be 1663.8. So a few feet lower than what the hospital has to be built to, but several feet more than it would have to be built to if it was just built to the BFE, or even for that matter, let's say the local ordinance said BFE +1, they would be building to 1656, whereas according to 2424, they should be building to 63.8. And then finally, if the community wanted to build a house or a subdivision or a risk category 2 building, let's say they were building it here to the east of the hospital. So in theory, this is outside of the special flood hazard area. Currently, most communities wouldn't regulate this construction, but under 2424, if they adopted it, they would be required to, and they would have to figure out what the 500-year flood elevation is. In this case here, I wouldn't need that web tool to help me. I know what the 500-year flood elevation is. I know it's 1662, so no inputs for me to make, and that would establish the 500-year flood elevation or the design flood elevation for a risk category 2 building.
Manny, I've got a question.
Sure.
Seal and I have looked at ASCE 2424 and looking at the different classes, and I know in ASCE 2424 it's descriptive and it has some examples of what each class type of a structure would be. But I've also found that there are some cases where I'm never quite sure. Is it a 3 or is it a 4? Is it strictly just a best judgment call kind of a situation, I assume, in those cases?
I think so. I think that for me, one of the gray areas it gets into is there's like water treatment plants and utilities and things of that nature. And it talks about if they service a hospital, let's say that brings them up to a 4. But for the most part, I think most of your critical and essential facilities would fit into that 4 area. Things like schools, maybe most of your utilities, your treatment plants, things of that nature, they fall into that 3. And then your residential and a lot of even your commercial spaces like your stores and things of that nature, as long as they don't have a pretty high occupancy number, then they're likely going to fit into that risk category 2. But
yeah, I know we were looking at a municipal well and debating, is it a 3 or 4? I think we decided upon a 3, but it sounds like maybe if it's strictly serving some like a hospital, maybe it could be a 4.
Yeah. Normally, what we see is if it's at the community level, I'd say most people interpret that as a 3. Let's say you have a substation or some kind of utility infrastructure that's specific to that hospital, then they'll in essence increase that to a 4 and make sure it's. I'll use a substation as an example. Potentially, there's some redundancy, hopefully, in that system to reach that substation across the grid, if you would. So the idea is that you're trying to keep that asset, if you would, as high as possible, so that if that utility can service it, that you didn't lose it along with everything else throughout the grid. There's some gray factor, if you would, in terms of whether something's a 3 or 4, especially when it comes to infrastructure.
Thank you.
All right, I'm going to hop into the last topic then here, and at least with respect to the key changes in 24.
Did you say ASCE 2424 was already adopted by International Building Code?
It has not. The International Code Council is in the process of updating to the 2027 edition of their code. So the IBC and the IRC, I actually have a slide on it too at the end. They have not finished that process. So there was one hearing in Orlando here in April, and there's another hearing coming up later this month in Cleveland that will decide whether or not 24 is adopted into both the International Building Code and the International Residential Code for the 2027 edition. The 2024 edition of the IBC and IRC, or the I codes, those have adopted ASE 2414. And I think I want to say ASE 2414 has been in the I codes since the 2018 edition, so 18, 21, and 24. And then I want to say before that, 2405 was in the 15, 12, 9, and 6 edition of the building code. So I think since about the 2003 edition of the building codes, ASE 24 has been incorporated. It's just a matter of what edition, 2405, 2414, those two have been adopted. Right now, 2424 is to be determined. Based on the April hearings, it does look like the IBC is going to adopt ASE 2424, but the IRC is not. That's what it looks. At least that's what it currently looks like. But hard to say what the vote will be like in Cleveland later this month.
Okay, thanks.
All right. So again, I covered elevation. I covered floodplain extent. The final topic I'll focus on is dry flood proofing. So I think outside of those two topics of elevation requirements and extent, this is the next biggest change to ASE 24. And in the 2024 edition with respect to Chapter 6, so Chapter 6 outlines the dry flood proofing requirements in ASE 24. And for the sake of time here, I just focused on a couple key topics here, but there are things like new definitions. There are clarifications on opening barriers versus temporary flood walls and things of that nature. But I'm going to focus specifically on shield types, 2510, and then planning and inspection requirements. So with respect to shield types here, so think of these shields as measures that are needed to just help finish closing off the building. So in essence, dry flood proofing, if you're not familiar with it, you're keeping water from coming into the building. So you make those walls substantially impermeable. The walls keep the water out, but you still have to be able to get in and out of the building. And normally speaking, that's typically a door, things of that nature, right? Sometimes folks will construct stairwells that go up and down, but for the most part, most architects and engineers, they'll keep that door at the same level. The walls are made to keep the water out, but they have to put a temporary opening barrier up to keep water from coming in through that door. And these are called shields, or these are defined as shields in the standard. And there are new requirements for shields in Chapter 6 of ASE 2424. Two things in particular. First, you notice here that there are different requirements for new construction versus substantial improvement. So we have two different sets of categories for new versus substantial improvement. And this is relatively new to the standard. There was very few things in ASE 2414 that differentiated between new and substantial improvement. So new is something that's being built for the first time, or at least that's the way I look at it for this slide. Substantial improvement is more like a retrofit. So the committee outlined different requirements for something that's being built for the first time versus something that's being retrofitted. The other difference that you'll see here with respect to the requirements for these shields is whether or not they're contingent or permanent. By contingent, this means that the logs, they're removable. They can be stored they're stored somewhere. Versus permanent, that shield has to be there 24/7. So the more critical the building, you'll see here, risk category 4, the more permanent that measure needs to be. So if you have a hospital, you had a door at a hospital, an exterior door, and you needed to protect it, those measures would need to be permanent. This is one way of doing it. There's also shields that come out of the ground. There's shields that slide over. I'm not saying this is the only way to do it, but this is just trying to provide you an illustration of a permanent measure, if you would. And then these are the contingent ones. And you start seeing contingent measures are allowed for less critical building, but not risk category 4 or flood design class 4 buildings. And then to further allow for different levels of risk, if you would, is whether or not those contingent measures have to be stored on site or not. And ultimately for new construction, the expectation is that those measures be stored on site. For retrofits, there is some more leeway in terms of when measures can be stored on or off site. Another piece related to dry flood proofing is the testing requirements for these shields. And in new construction, all the shields must be tested. So your design needs to incorporate those tested shields. Let's say there's a product out there that was tested to an opening that's 10 feet wide to 4 feet in height. So if you keep out 4 feet of water, then your new construction, that's the limitation of the size of that opening. It can't be wider than 10 feet, and it cannot exceed more than 4 feet of water that it needs to keep out. You're limited to using the products that have been tested to the standard. For retrofits, there is leeway that allows for a design professional to go beyond what that was tested to. And the thought process here was that for a lot of retrofits, you have a lot less control over the size of that opening. So potentially the design professional, the architects, the engineers can work with the manufacturer to confirm whether or not they feel that product will meet. Let's say you have a 12-foot opening, and let's say you have to keep 6 feet of water out. Well, that product was only tested to 10 by 4. Maybe they can evaluate with the manufacturer or potentially do limited testing, not do the entire testing that's required to meet 2510 to confirm that that product can meet those requirements. So again, the same difference as the previous slide. You do have some allowance for differences between something that's being built new for the first time versus something that's being retrofitted. And then finally, for planning and inspection requirements, there are changes related to plans at the time of construction. They should outline routine inspections and deployment requirements within those plans. The plans need to meet certain implementation requirements, specifically timing, how much time it takes to implement these measures. So the more critical the building, the less time you have. So let's say I'll use that hospital example. If you're dry flood proofing it, all those measures should be able to be implemented within 4 hours. Maybe for a flood design class 2, let's say a storefront building, those have 12 hours. A school would potentially have 8 hours as a flood design class 3. And then on the couple slides back, I showed you the emphasis on having permanent measures. So the committee felt that there was a possibility that we're going to see a lot more use of passive measures. Passive measures, they in essence don't require any level of human intervention. And one of the lessons learned with those products is that they've actually been deployed and the building owners didn't even realize it. Rain, let's say you had some rain, storm water, that passive gate automatically popped up. Well, now you've impeded that point of egress. And we wanted to make sure, the committee wanted to make sure that was being conveyed in some way, shape, or form to the facility manager that your passive measures have been deployed. So if you rely on passive measures, there has to be some kind of method to alert the building facility owner that those measures were done. All right. So hopefully those 3 topics, gave you an overview of what's going on in 24. There's several other changes in the publication, in the standard. One of them has to simply do with flood loads, and a lot of the changes that you see in 24 are due to the new requirements for estimating flood loads in ASCE 7. Again, this elevation requirement, this floodplain extent requirement align with a lot of the changes that occurred in ASCE 7 22 Supplement 2. If you're not familiar with those changes, encourage you to take a look at FEMA publication. Pretty easy number to remember, 2345. It outlines what are the requirements that are out there for flood loads now. And then this slide here, really, I could spend a whole another hour or two covering all the different changes that were highlighted. To give you some context, from ASCE 2405, from 2005 to 2014, I think there was about a dozen changes highlighted in the preface of ASCE 24. In ASCE 24 2024, there was 29 items that were highlighted in the preface from 14 to 24. So I tried to focus on probably the 3 key ones, especially elevation and floodplain extent. To me, that's by far the most drastic change here, especially for communities that reference this or looking to exceed the NFIP. But there's other topics here as well. And the ASCE 24, the standard, you can get to it online. If you log in with your ASFPM membership, you can view the standard. If not, it's something your community may have a license to get to it as well, or you may have to purchase it from ASFPM. I'm sorry, from the ASCE or the American Society of Civil Engineers. And also, the Association of State Floodplain Managers has a model ordinance that they've put out there. If you're interested in seeing that, that's available online. You can search for it in the library, or if you go here to members and communities, there's the non-structural floodproofing committee. And I think that's where ASFPM has made this model ordinance information available for now. And they also have a PDF of a webinar that was delivered on ASCE 2424, similar to this one, probably a little bit longer, but again, that available is out there. That information is available out there. Again, both of these, both the standard and this model ordinance, are available on the ASFPM website. The question was asked earlier about the I codes, and this was the vote for incorporating ASCE 2424 into the 2027 edition of the IBC. So 13 of the 14 members voted yes on this in Orlando. Hopeful that well, for me personally at least, I'm hopeful that vote will remain the same in Cleveland later this month. So that will be for the IBC. On the IRC side, on the other hand, it was not. It was disapproved by a vote of 7-10. So it does not, at least currently, look like the IRC will incorporate 24. I'm a member of the ASCE 24 committee and went to these hearings here in Florida in April and plan on going up in October to provide testimony. So we are going to present this again to the IRC committee, but not really sure what the outcome will be. And with that, kind of just wrap up here with my point of emphasis on most of this is to, one, spread the word about the new requirements that are in ASCE 24, and really just trying to make sure that we're not continuing to develop or build in a way that we're contributing to tomorrow's problems. So kind of just emphasize to folks to just look at your practices and consider what the design and construction practices are in your community, and basically just see if we can build this right the first time, and hopefully not have to be continuing to contribute to those flood losses that we're seeing in the future. With that, I'll open it up to any final questions there may be and turn it back over to Seal and Gary.
One thing I did want to bring up was we had shared with Manny that our state floodproofing rules, which for folks in Minnesota, that's Minnesota Rules 1335, they still refer to the 1972 Corps of Engineer floodproofing regulations, which are, of course, ancient. And we were going through the process of getting the rules updated a few years ago. And I did reach out to my contact over with who works with the building code area, Department of Labor and Industry. And he said that the Minnesota Rules 1335 work got derailed by our statutorily mandated building code adoption cycle. We're just finishing up that work and we'll soon be getting back to the Minnesota Rules 1335 update. And in the draft rules that we had earlier, we were looking at adopting ASCE 2414. And so my contact was asking whether we're going to want to get our technical advisory group back together and have a look at 24-24. And I'm going to be letting them know that, yeah, I think we should be getting our technical advisory group together and at least having a discussion about that. But at a minimum, hopefully we'll be getting it updated to the 2414, that'll get back on track, because there are a lot of the steps in the rule making process. We did go through that a couple years ago. Well, I thought there was a lot of great summaries there, and I'd heard some highlights, and just a comment there, important work. Thank you to both of you. Those first 5 minutes where you're giving some of those statistics there, Manny, that was some really interesting perspectives there for us to be looking at, and very good examples. I would like to see us looking at examples of what's the difference between the 100-year, 500-year in more parts of the state, and doing some of the evaluations you were showing for those example areas. Again, thanks everyone for attending. Appreciate you being here. Especially appreciate our presenters.